Hi everyone, welcome to the weekly GBO Tech Talk. So today I'm going to be talking about Azure Cosmos DB, which is it's Microsoft's latest cloud-based NoSQL database solution that they have come up with. So just to give you a little background on how and why I decided to choose this as the presentation. So I think most of you know that we in the Titan project we use Cosmos DB as our database. So this came as a requirement from our product owner at the very beginning of the project. Like at the beginning we had to let go of most of the things that we are normally familiar with. We had to get rid of Angular and go with React, and also for the database we had to get rid of our beloved SQL server and go with Cosmos. So now it's been close to a year since we've been working with this, and personally I have found that there are some good things as well as some bad things about this database solution, and that's why I thought it might be worthwhile to actually talk about it. So that's that, and so just a brief overview of what I'll be talking about. So of course you can't talk about Cosmos without talking about NoSQL, and also after that the Azure storage stack, and then some basic concepts, and also I'll talk a bit about pricing, and then we'll have a demo, and then some real world users who actually use Cosmos as a database, and finally the limitations that it has, and a summary to finish. So NoSQL. So I think most of you have heard this term before, and you basically know what it is. So it's in the early days, what people said was it was like not SQL or like non-SQL, but nowadays the definition has somewhat changed, and now people refer to it as not only SQL. So it's like in NoSQL we aren't kind of restricted by the SQL and the relational structure, and we can basically have data in any form that we want. That's the basic concept. And especially in NoSQL databases, so usually in relational databases we deal with tables and rows of data, but mostly in NoSQL databases it's we have collections, and then we have documents. So each document will have an item of data like that. So MongoDB is like the most popular NoSQL database out there. They are the ones who actually revolutionized the whole NoSQL concept, and after them there were some other solutions that came up, and now Microsoft has come up with Cosmos DB for the Azure service platform. So the Azure storage stack. So when you are building a solution using Azure, so you have quite a number of options when it comes to data storage. So if you are basically you have like just some primitive amount of data with not many complexities, you can go with the Azure simple storage, which has tables, files, or disks, and queues, and the blob storage. But when your data grows like exponentially and you have to deal with a very large amount of data, there are other options. So we have Azure SQL database, which is their relational option, and also data lake, which is a new thing that they have come up with when, especially in instances where we want to manipulate big data and perform analytics, things like that. And finally, we have Cosmos DB, which is the NoSQL solution that they have provided. So the data model, so similar to most other NoSQL databases, in Cosmos DB also we are dealing with documents. So in a single database, it will have multiple containers. So this is like sort of analogous with what we know as collections in NoSQL databases, but it's sort of like a bucket of data which contains a set of documents, something like that. So at the very end, we have the most granular part, which is the document itself. So we can have like a number of containers in a single database. So just to give you an example from our project, so in Titan, when we started the project and started using Cosmos, we only had one container and it stored all the data. But now we have like sort of matured, and we now have three separate containers. So we have the default one, which contains all the data that comes out of the web portal, and then we have another container which contains all the events and related data. Which the reason is that there's when we go down the line, there's going to be an exponential growth in that container. And then finally, we have the report related data, where the data we need for reports, we get it from that. So like that, we have sort of classified into different containers. And then there's this other concept called partitioning. So basically, the thing is, like, we in a single container, we can partition our data into like different partitions. So it's like you have the main thing to realize is that you have to understand the concept, and you have to develop your partitioning strategy for your application based on the on how you are querying the data. So it's sort of like what you want to show in your application at a certain time. According to that requirement, you have to consider about these partitions. So again, as an example, I can consider our Titan project. So in our project, basically throughout the entire web portal, there is no place where we actually show data for all the customers in the system. So it's only like we have in any page, we have to select the customer before we actually show the data for that customer. So therefore, in our partitioning strategy, for our default containers partitioning strategy, we have the customer ID as the partitioning key. So there's this partitioning key concept. So based on that partitioning key, only the partitioning will happen. So in our project, we are partitioning the data according to the customer. So at a single time, we'll only be querying from a single partition, so a single customer. So the thing is, if you can have like cross-partitioning queries, but it's going to affect your performance a lot. So we have experienced that firsthand in our project. So yeah, it's important that you develop your partitioning strategy accordingly. And in Cosmos DB, so it has endpoints for several different APIs. So they provide proprietary SQL API, which is kind of like the most popular option that people go with. It's the same thing that we are using in Titan. So in that, we have the ability to write things like stored procedures, triggers, and user-defined functions within that API. And there's also endpoints for MongoDB, Gremlin, Cassandra, and Azure Table Storage. And I saw recently they have also included one other, I can't remember what, but they have several other options as well, which can be used. So next, there's another concept called tunable throughput. So I think most of you know what throughput is. So throughput is mainly the amount of data that kind of flows through an application in a given time. So this throughput is actually customizable or tunable within Cosmos DB. So that means the developer can specify the throughput to match his application's load. So that will be defined when we are creating the database. And also this throughput is actually measured in request units per second. So it's called RU. So they have defined one RU as the if you are querying for a document of the size 1 kilobyte, so that will consume one request unit. So that's the baseline. And also, if you are updating or deleting a record, they are saying that it usually takes 5 request units. And if you are performing larger queries or stored procedures, things like that, it will consume hundreds and maybe even thousands of request units. And the other thing about throughput is that it can be provisioned at either the container or the database level. So you can provisioning at the database level would mean that it will be sort of common for all the containers. But again, you can again provision throughput for an individual container as well if you want. And talking about the distribution, so like Cosmos DB is available in any of the Microsoft Azure regions. So currently I think there are more than 50 regions across the world. So you have the ability to work, like construct the database in any region that you want. The thing is, like, as a developer, you want your data to be as close to the users as possible. But it won't be the case if you have users throughout the world. But usually that's how it happens. So like you can choose where you want your data to reside. And of course, you can add and remove these regions from your Cosmos DB database, and it will not affect you won't have any downtime, or it won't affect the performance. And there are also some things called data consistency levels. So this is also something that's customizable by the developer when specifying the database settings. So I think they have around 4 or 5 consistency levels. So data consistency mainly talks like when you are executing some transaction on the data, how the data should actually change and manipulate. That's the main concept behind data consistency. So that's also customizable for certain levels. And there's also this concept of single master versus multi-master. So initially when Cosmos DB came out, it was single master, which means that say you have a globally distributed database across multiple regions. You can read the data from any region, but you can only write the data from a single region. So that's why it's called single master. But recently they have moved to this multi-master module, where like you can write the data from multiple different regions. So that's multi-master versus single master. And talking about the pricing, so the pricing of Cosmos DB is based on the throughput that I mentioned earlier, the provision throughput, and the consumed storage by the hour. And also the storage is built for each DB use. So they have given some figures in their website. So if you are using a multi-master solution for 100 request units per second, that will be the rate per hour, and it will be half that for the single master. And if you are using the SSD storage per GB for 1 month, that will be the amount. Just some figures. Okay, so I think we can quickly move to a demo. So first thing we have to do is actually create a database. So for that, we have to go to the Azure portal, and it has this Cosmos DB section. So first thing you want to do is create a Cosmos DB account, which I have already created. So you can just put this at here. So when you are creating an account, it will ask for basic details like the subscription, the resource group, name, things like that. And here you can specify the API that you are intending to use. So for this demo, I'm using this OSQL API. And also you can enable Apache Spark for this solution. And here you can choose from a list of locations where you want this to reside. And this geo redundancy setting is used to enable this global distribution that I talked about earlier. And here this is the multi-master, single master toggle. There are also some other like virtual network configurations which are like I won't cover it. So that's that, and you can simply create an account. So I have already created an account for this demo. So once you create an account, you can basically start by adding a container. So adding a new container will automatically create a database for you. So it will ask if you want to create a new or use an existing. Again, I've already created that in my solution. And you can supply the ID of the container, and this is what I mentioned before, the partition key. So basically this has to be like So when we are dealing with Cosmos DB, we are dealing with JSON documents. So this partition key field has to be a field that is included in that document that you are using. So according to the value in that partition key field in the document, your data will be partitioned to the relevant partition in the container. So for this demo, I've actually used a field called category for my partition key. And at the very bottom, you have the throughput that you can specify. So you have a range of 400 to 100,000 RUs per second. So you can put whatever amount you want and you'll get the pricing below that. So that's how you create a container, and once you have created a database and a container, so it will say that it's SQL API at the top, and it will show all the stored procedures, functions and triggers that you have created. It will show there, and in this item section you will be shown the documents in this container. So currently it's empty. So either you can add a new item simply by clicking this button, and it will give you a JSON document which you can populate with the data that you want and simply click save. So, but for this demo, so I'll be using a separate application that I created. So this is a basic web application that I created for this purpose. So this is sort of like a task list. So I'll show you. So basically, in this application, you can create, edit, and delete a list of tasks. So as you can see in my data model, first thing is when you are connecting this application to Cosmos DB, you can have your settings in the the app settings configuration. So what you want is, if you go back to the Cosmos DB account, at the left side you will have a section called keys. So here you will have the URI, primary, secondary keys, things like that. So you will have to use this key when you are trying to connect with your Cosmos DB instance. So you need both the URI and the key. So this is what I have provided here. The endpoint is the URI and the auth key is this key. And also additionally we need the database name and the collection name as well. So after you configured that, so I have so this is basically just a very simple architecture. So ideally in an enterprise level project, you would want to have your data access layer separate, probably in a separate project itself. That's how we have it in a Titan project. So there you can write your own wrappers for the Cosmos DB connectors. So in order to connect with Cosmos DB, we also need a NuGet package. So Microsoft has provided that for us, which you can see here. So Azure.documentDB. So you can use this client library in order to write your Cosmos related implementation. So I have created a separate class called documentDB repository. So here what it does is it basically reads the database and collection IDs and creates a document client. So in order to, so this is what you actually connect with your Cosmos DB instance, this document client. So once you initialize this client, so there are some methods written, like if you want to create a database, create a collection, you have to use that same client object. So if you just go inside this ABI, so it has a lot of different functions that you can use. You can create databases, collections, and single documents as well. So you can read, replace in the sense update, and delete, create, upsert, things like that. So there are a lot of different options that you have. So for this demo, I've just used some simple methods. So in my so first I'll show you the create method. So here I can simply create an item by having the before that I'll show you the model. So this is my item model. So here I have used the JSON property decorator in order to provide a nice name for my property. So this is the model of the document that's going to be saved in the database. So you can see here I have this category field, which is what I have chosen for my partition key in the database. So you have to have that inside this model, the partition key. So once I create a document, what it does is it basically calls this create document async method, and you have to first create the document collection URI. So for that you need the database and collection IDs that have been specified earlier, and with that you have to provide the item. So it's very basic and easy to understand the underlying implementation. So if I just create a new task, so I provide the category as writing. Okay, so I've created a new task. So going back to the database, so I can use this data explorer to query and view my data. So now you can see that there is one document, and you can see the ID, which is a GUID in the left side, and the partition key in the right side. So this has been, what this means is this document now resides within the writing partition of this container, and inside you can view the data that has been created, and there are also some meta fields as well. Yeah. Similarly, you can like for the update and delete as well, it's pretty much the same thing. You can just update the data and view it in this data explorer. So this is entirely a JSON document, so you can see that it's basically just key value pairs. That's how your data is stored. It's the same case for any NoSQL database. So yeah, and also you can delete. It's basically simple tasks. So that's how you create a database using Cosmos DB and like querying and retrieving data. And the other thing is, so if I go to my controller, so here in the get query, I have written it like this, but since we are using ASP.NET, we have the ability to integrate LINQ into this as well. You can write these predicate logics using LINQ as well. However, there are some limitations which I will touch on later. So basically, that's that. Yeah, and so some real-world users of Cosmos DB, we have Microsoft Office, Active Directory, MSN, Skype, and Xbox. So you can see that there are some high-profile companies who actually use this as their database solution. And another important thing to talk about is the limitation. So as with anything in the world, this also has limitations. So one thing is the backup and restore features. So in Cosmos DB, you are able to back up data to a certain extent. So for example, at the database and collection, the container levels, you are able to back up and prevent data from being corrupted. But at the document level, it's not possible according to what they have said in their documentation. So that's one limitation. And also, if you want to restore your data, you have to like create a ticket with Microsoft and wait for that to be approved, things like that. So it's not a very straightforward thing, backup and restore. And talking about the support for .NET and LINQ, so I think we have encountered this in our Titan project as well. So it's very it has only limited support. Like for example, things like some things that normally developers would assume should work out of the box does not actually work with Cosmos DB. For example, the LINQ query we use called any, so that operator is not supported in Cosmos DB. So instead of that, we have to use some workarounds for that. And again, just to give you an idea on how confusing this is, so if you go to a Stack Overflow, so I just search for the questions tagged with Cosmos DB and LINQ, and there are over 100 questions, which is quite a lot when considering two separate technologies bound together. So you can see how most developers are getting confused by this. It's like they're expecting it to work, but it's not actually working. No. Okay.
Yeah, pretty like few months ago.
So
There's an entity framework for provider for Cosmos DB.
which overcomes the.
That I don't know.
So I actually searched just a couple of days back, and still people are like complaining about the support things. So I think some things may be fixed, but still some things need to be improved. The main thing is it's still in the developing stage. That's the main issue. And also it's the same with the basic SQL functionality within Cosmos as well. So you can use basic SQL syntax like count, minimum, maximum, but things like group by, things like that, they are not supported. So that's also another limitation. And also Cosmos DB supports only for pure JSON data type. So providers like MongoDB and Cassandra, so their databases actually allow for the various different complex JSON data types, but here that's not the case. So just to take an example, so if you want to save a date time field in Cosmos DB, you can't just save in the data type that you want. You have to use the available data types that we have. So you should either convert it into like an epoch, a number, an integer, or else an ISO string, something like that. So there are limitations there as well in the data types. And just to give a summary before I finish, so most of you might be asking why, if at all, we should go with something like this as a database solution. So the main advantage I see is that if you are working in a project which like has tightly coupled and like most Azure services connected together, I think this as a database, Cosmos DB would be a like a rational solution. But again, as I mentioned, there are some severe limitations still in it. And of course, the advantages that you get from NoSQL that I mentioned earlier, of course, applies here as well. So it's basically a trade-off between what you see as advantages into what you see as the limitations. So I think mostly it depends on the type of the application that you are working on, as well as the nature of the various data that you are manipulating. So yeah, that's that, and that's pretty much what I want to talk about.